So this is basically the code example of the lecture that I just delivered. So here I have deliberately used Streamlit since at this point most of the students are not aware of full stack development. So fast API or API development with even a minimal UI HTML file or a React based file will be very difficult. So here we do have initial imports. All the modes are basically mentioned at the top, and then this load.env load.env is basically loading all the secrets from this environment file. So here we have two secrets, Gemini API key and Pinecone API key. You can go to AI Studio and create your own Gemini API key, and similarly you can go to Pinecone and create your own API key. I'm not doing that right now due to time limitations. I have already created and put it here. And then we are basically importing those secrets within our code. This namespace and index name is for the Pinecone index that we will create. This chunk size, which is set here, is 1000. So this means that all the chunks that will be stored into the vector database will be having 1000 tokens. Here we are making an instance of the Pinecone with its API and also an instance of the index. Here we are making an instance of the embedding, which in this case is open with all mini LM L6V2, which is a sentence transformer. So this will be downloaded locally. The first time you will run it, it will take some time. I have already run it so that it can be demonstrated within a short period of time. And then we are making an instance of the Gemini client by passing its API key. This title and this st.write will be displayed on the Streamlit application. This is very simple to understand. And then this upload file with file uploader will basically show a file uploader. Once I will run, so you will see that as well. And this is one pipeline, this is the second pipeline. So this one is the upload pipeline. It is exactly similar to what we learned in the image that I was showing. So once someone upload something, so it will go to this PDF loader, and then this loader will convert it into pages by using load and split method. Once that's done, then we have a text splitter. Because why do we even need this splitter? Because let's say if document has 10,000 pages, so and 1 million words, so we just cannot store that as a single chunk. We need to make small chunks, because when passing it to the LLM, we cannot pass 1 million words directly, else it will again overflow the context window. So we do need to use some chunking strategy here. Recursive character text splitter is used. So the chunk size which was set earlier is 1000, and this is overlap of 200. So this means what will happen? The first chunk will comprise of 0 till 1000 token. The second chunk will not start from 1001, rather it will start from 801. There is an overlap of 200 and will end at 1800. The third chunk will again not start from 1801, rather it will start from 1601 and will end at 2600, to make sure the information is not distorted, because it could be possible that due to this, if there is no overlap, so we can miss some important information. So just to make sure that we do not miss any information, there is an overlap. And then it's stored into documents, and then with the help of this loop, all the vectors are then stored into the vector database. Here I have deliberately mentioned a sleep time of 2 seconds to make sure that the free tier of Pinecone does not get exhausted by excessive API calls to it. So this sleep time ensures that after every batch is inserted within it, so there is a sleep time. So this pipeline will only trigger once we upload something. This is the RAG pipeline. So once someone puts a question here in the text box and submits, if the question is empty, so you will see this, that please enter a question. In case if the question is not empty, you will see a spinner with this message, getting your answer. And again, what will happen? The same embedding model will basically receive your query, and that query will again go to the vector database, and there will be a semantic search, and you will get results. Here I have put 10, so this means that we will only get 10 chunks. We can use 100,000, whatever you want, but the more the chunks, the more is the chance of hallucination. So we do not want to keep big number here. And then once we have retrieved those results, so we will basically pass that to the LLM, in this format. This is the prompt where we do have this context and the original question so that the LLM can respond. So here we are passing that prompt that we just built here, and then the answer will be displayed here. So this is as simple as that. Now I'm running it. Firstly, I already have my virtual environment activated, but in case if you do not have, so you can create your own virtual environment. Mine is already there, so that's why I got this. And then you need to activate it. Once done, so you need to install the requirements. I have already installed it, so I'm not executing this command. And then I need to start. Since this is not a conventional Python file, it does have Streamlit, so we need to use this command Streamlit run and whatever the name of the file is, which in this case is rec.py. So it will basically open the application in my browser. It is taking some time because the open weight embedding model is loading. So while loading, it takes some time. Now it's loaded. So I will upload a document here. This is a document. I have made this bespoke document because I want to test. I will show once I upload it. Now it's uploading. Meanwhile, it's uploading. Uh, I'm going to open the document. So this is a document. I have made a fictitious document employee guide for ABC State Oil. So let's say about specific information. So this is the email. So I can ask a question that what email should I use for cyber security to contact cyber security. So I'm going to use this query. So these 13 chunks are embedded, stored in the vector database. So now it's getting my answer. And the answer is this. It has this briefly told me what the answer is, and this is the retrieve context that is basically retrieved from the vector database as a part of the uploaded document. We can upload n documents. It's not that we can only upload one. We can upload as many documents as we want.